Hello, everybody. This is Mr. Fasoni. Today we'll be going through another section in Chapter 3 of our Algebra 2 class, Quadratic Equations and Complex Numbers. And we're going to be going over Chapter 3.4, which is the Quadratic Formula, which is kind of the big deal of this chapter. We've gone over lots of different ways to solve quadratics, and this is kind of like the master key that opens up any quadratic. Work for any of them, and it's relatively straightforward to use. So let's get going. Our goals are to solve quadratic equations using the quadratic formula, analyze the discriminant to determine the number and type of solutions. So the discriminant is a new thing we're going to be learning about. And then we're going to do some solving of real life problems actually in class, so just throw that out for right now. So concept 1, can we solve standard form for x by completing the square? So what I mean by that is, can we solve that format without numbers in it? We just have an a value, a b value, and a c value. So we've got stand-ins basically. This is the generalized form we're going to try to solve. Well, it turns out we can. So I'm going to do this to the right here. This is a little bit abstract, but what this is going to result in is kind of a neat solution here. So if I got the standard form of quadratic equation, ax squared plus bx plus c equals 0. I want to solve it for x. Well, in the last section, we learned how to complete the square. So if we use that same idea, we can actually solve for x. So to start off with completing the square, I'm going to move the c value from the left side to the right. So I got ax squared plus bx equals negative c. All right. So we're making some progress. We got to get x by itself, though. Well, the next thing I'm going to do, remember when I'm completing a square, it's much easier to complete the square when x squared is just x squared without a different number in front of it than 1. With 2x squared, 3x squared, or whatever, it makes it kind of difficult. So what we're going to do is we're going to divide both sides of the equation by a. Get that a away from the x squared. I mean, a's cancel here, so I'm left with x squared plus b over a times x equals negative c over a. So this is exactly what we want. Now we've got a situation where I can complete the square. So remember, when we're completing the square, it's kind of a 3-step deal as well. We look at that b value. Now today, the b value is b divided by a, because we're doing this very abstractly. But what I can do here is I can look at this b value, I'll put it in quotes. In this case, it is b divided by a. And if I wanted to diagram this out, remember I could diagram the completed square out like this. X times x is x squared. And then I've got b over a times x. So this part across the top is b over a. Remember, my first step of completing the square is to take that b value and divide it by 2. Well, if I do that here, I'm going to get b, if I divide by 2, I'm going to have a 2 down in the denominator. So b over 2a. Graphically, what I'm doing is just cutting this square or this rectangle, whatever we want to consider it here on the right, cutting it in half. Oops. So instead of b over a times x, I've got b over 2a times x and b over 2a times x. And up here becomes b over 2a. So remember, graphically, now what I'm going to do is I'm going to tear off this far right piece. It's like I've cut it off. And what happens is I get x squared, still on the upper left corner of this diagram. I got b over 2a times x. And then that other piece comes down along the bottom here. So I've got basically 3 out of 4 parts of my square completed. The last part I need to fill in is this lower right-hand corner. I need to figure out what that is. But remember, that just means I'm going to be multiplying these two values together. So I'm going to be multiplying b over 2a times b over 2a. In other words, I'm taking this second value from this list I've got here in the blue, whatever my quote-unquote b value is, I'm squaring. b over 2a times b over 2a, or in quotes b, because remember when we're talking about quadratics with actual numbers, that coefficient in front of the x is our b value. So I'm taking b over 2a and I'm squaring it. What goes in this little corner here then is going to be b over 2a squared. So what I'm going to do is I'm going to add that to both sides of my equation. I'm going to add b over 2a squared to both sides. And what that results in is the following. I've got x squared plus b over a times x plus b over 2a squared. And the right side is going to be equal to negative c over a plus b over 2a squared. Well, the nice thing about this now, on the right side of the equation, what I can do is I can rewrite this, not the right side of the equation, I'm sorry, the left side of the equation. I can rewrite that as a binomial. Remember, I've created a perfect square, trinomial. So I can rewrite it based off of this information here. I've got my x squared, I've got my b over 2a squared, and then I've got b over 2a to the x times x times b over 2a times x, which is my middle portion, b over a times x. So what I can do is I can rewrite that as a perfect square binomial. I've got x, those are my x's, plus b over 2a, these are my b's over 2a's, squared. So I'm going to rewrite this left side as x plus b over 2a squared, which is equal to negative c over a plus b over 2a squared. Okay, so my next step, if I was solving a quadratic normally, would be to take the square root of the left and right sides to get rid of that perfect square on the left. But I got to do some reconfiguring of the right side first. So first thing I'm going to do is I'm actually going to multiply out b over 2a squared. Remember, that's just b over 2a times b over 2a. Well, if I work that out, b over 2a times b over 2a becomes just b squared over 2a times 2a is 4a squared. So I'm going to bring down this other part. We've got negative c over a plus b squared over 4a squared. And on this side of the equation, I still have my x plus b over 2a squared. My right side's still not pretty. I want to make my denominators match. So to make these match, I need to multiply the left side by 4a, because I need to make the denominator go from a to 4a squared. Well, to do that, a times 4a will give me 4a squared. So what I'm going to do is I'm going to take this right side of this negative c over a on the right side of the equation and multiply both the numerator and the denominator by 4a. In other words, I'm going to do this. I'm just going to leave the second part alone because it already has a denominator of 4a squared. So when I do this, negative c times 4a gives me negative 4 times a times c. And now my denominator is 4a squared. So by doing this, it looks like it's made it messier. But what that allows me to do is now I have these matching denominators. I've got matching denominators. I can put all the stuff in the numerators into one big numerator. So let's go ahead and do that. I'm going to rewrite this. I'm going to add b squared and negative 4ac. So I'm going to rewrite it like this. B squared minus 4ac over 4a squared. And I'm going to bring down the left side. It's a lot of work, but we're almost there. So what I can do now is I can take the square root on both sides of the equation. So I'm going to go ahead and do that. Let's use green. Square root of both sides. This is crazy. Left side is nice. I've got a perfect square. Square root gets rid of it. So I've got x plus b over 2a. Notice that we're almost to the point where x is by itself. The right side is going to be a mess. I'm going to rework this right side really quick. Remember, the quotient rule allows me to do this. If I address these individually, the top I can't really do anything with. It's too much of a mess. So I'm just going to leave it as b square root of b squared minus 4ac. The bottom, though, I've got a 4, well, the square root of 4 is 2, and I've got an a squared, well, the square root of a squared is a. Remember, though, I'm solving for a value x. So when I did this square root, I'm actually going to have a plus or minus sign with this answer. So my plus or minus sign becomes plus or minus square root of b squared minus 4ac all over 2 times a. We're almost there. Last step. I'm going to subtract b over 2a from both sides of the equation. These are going to cancel. And finally, I'm left with x equals negative b over 2a plus or minus the square root of b squared minus 4ac all over 2a. Well, what's nice about this is I've got a common denominator. So I can clean this up one last time, and I end up with x equals negative b plus or minus the square root of b squared minus 4ac all over 2 times a. And now I have solved for x. Excuse me. I've solved for x. All that work, all this crazy, crazy work, I went past like a bunch of different slides. If I zoom out, if I zoom out, geez, this is a lot of work. There's everything. So we changed from ax squared plus bx plus c equals 0. We solved for x, and we found that x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. So this is a value for x that we can find with any quadratic. As long as we know a, b, and c, we can plug all three of those values in, and we can get our answer. So this is a very, very powerful thing. Deriving it is a nightmare. I don't expect you guys to know how to do that, but I wanted to show you how we can get there from the standard form equation. So what we have here is what we call the quadratic formula. I basically solved the standard form formula using the completing the square idea and found a way to solve for x no matter what x is. This is very, very powerful, and we can use this to solve any quadratic. So let's scroll back to our slides. So our slide said, can we solve standard form for x by completing the square? Yes, we just did. We found the quadratic formula, which is going to be on the next slide, so I'm not going to write it. So here's our concept. The quadratic formula. As long as a, b, and c are real numbers, and a is not equal to 0, which is our requirement for all of our standard form stuff, the solutions of a quadratic equation, ax squared plus bx plus c equals to 0, can be found by using this formula. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So this equation is probably the most important equation that you'll learn in Algebra 2. This is like the equivalent of learning the Pythagorean theorem in geometry. A squared plus b squared equals c squared. It's that important to the entire class. So please, please, please write this down. Make a note of it. You're going to be using it a bunch. All right, let's go through some examples. This is going to be quick. So solving an equation with two real solutions. I want to solve x squared plus 3x equals 5 using the quadratic formula. All right, let's go ahead and try it. A is equal to 1. B is equal to 3. And C, oh, I don't know what my C is yet. Let's clean this up first. I got ahead of myself. So I've got x squared plus 3x equals 5. So to fix this, I have to move the 5 to the other side of the equation, just by subtracting 5. X squared plus 3x minus 5 equals 0. Now I can find my a, b, and c. Nothing really changed. A is equal to 1. B is equal to 3. And c is equal to negative 5. I've got everything I need. Remember, I'm just going to plug it right back into the quadratic formula. The quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2 times a, not z times a, 2 times a. So let's plug in that stuff. I'm just going to put all the structure in there. All the values that are not are constants. So a is 1, so 2 times 1, 4 times 1. B is 3, so negative 3 and 3 squared. And then my c is negative 5, which goes right there. Remember, this square root goes over the entire thing there. All right, let's do some math. This part's real straightforward. It's going to be x is equal to negative 3 plus or minus 3 squared is 9 minus 4 times 1 times negative 5. Well, 4 times 1 is 4 times negative 5 is 20. I've got a minus sign out there. So I've got two negatives, the minus here and the minus there. They're going to turn into a positive. So this is going to be positive 20 all over 2 times 1, which is 2. We're almost done. I'm running out of room. Please zoom in. I'm going to have to zoom in more because there's a bunch of writing to the right. So I've really got x equals negative 3 plus or minus the square root of 29 all over 2. I can't really take the square root of 29. It's a prime number. There's nothing I can do. I can rewrite this though. I could either leave it like this, or I could write it as x is equal to -3 over 2 plus or minus the square root of 29 over 2. That's my general answer. Or if I wanted to write it twice, I could say that, I'll use this little space right here, x is equal to -3/2 minus the square root of 29 over 2, and x is also equal to -3/2 plus the square root of 29 over 2. 2 solutions, both real. So those would be my 2 x-intercepts. I, of course, could check this if I wanted to using something like Desmos. Go into the graphing calculator. X squared plus 3x equals 5. Plug it in. X squared plus 3x equals 5. Those are my 2 answers right here. They're in decimal form, but sure enough, those are my 2 roots. If I plug these into a calculator, I would get a value somewhere around -4.193 and 1.193. So we've got our 2 real solutions. All right, let's go ahead and continue. So sometimes we have a situation with 1 real solution. So we're going to do the same thing again. We're just going to solve using the quadratic formula. The beautiful thing about this equation is, or this formula, is that you can use it for any quadratic. As long as you can find your a, b, and c, you're good to go. I have 25x squared minus 8x equals 12x minus 4. Well, let's get stuff all onto one side of the equation. I'm going to subtract 12x from both sides. I'm going to add 4 to both sides. So minus 12x plus 4. These cancel. I've got 25x squared minus 20x plus 4 equals 0. Well, from here, it's very fast again. A is equal to 25. B is equal to -20. And C is equal to 4. I've got everything I need to do my quadratic formula. X equals -b plus or minus the square root of b squared minus 4ac all over 2a. Why my 2's keep on looking like z's? I don't know. That's still a terrible 2. So let's go ahead and plug in a, b, and c. X equals -b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. Okay, a, 25. 2 times 25. That's up here as well with the 4. B, -20. So I'm going to have -20. And I've got -20 squared. And then finally, my c value is going to be +4. All right, let's work this out. This is a little bit more, maybe some calculator work. No big deal though. Negative of -20 becomes +20, plus or minus. -20 squared becomes 400. Minus 4 times 25 times 4. 4 times 25 is 100, times 4 is going to be 400. All over 2 times 25, which is 50. We're almost done. I'm going to have x equals 20 plus or minus, well, 400 minus 400 is just going to be 0 over 50. Well, square root of 0 is just 0. Plus or minus 0 does nothing, so I can get rid of all of that. So really, x is just going to equal 20 over 50, in which that can reduce down to 2/5. And I've got one real solution. That one was a little bit faster because all that stuff in the square root canceled out. And again, I can plug this all into Desmos if I want. 25x squared minus 8x equals 12x minus 4. 25x squared minus 8x equals 12x, was it minus 4? And sure enough, there's my answer. 0.4, which is just the decimal version of 2/5. So I got my solution. Again, plug it into the quadratic equation, it works. All right, let's try something new. Complex solutions. So think back to chapter 3.2 and 3.3. Complex solutions. So we're going to have imaginary numbers in there as well as real numbers. So I'm solving negative x squared plus 4x equals 13. So I'm going to do the same thing I did last time. Subtract 13 from both sides of the equation. Negative x squared plus 4x minus 13 equals 0. My a value in this case is going to be -1. My b value is going to be 4. And my c value is going to be -13. Got all my components for my quadratic formula. It's like a recipe basically. X equals, and again, I'm going to write it out every single time to help embed this into your heads. 4ac all over 2a. So x is equal to, it's going to be negative b plus or minus the square root of whatever b is squared minus 4 times a times c over 2a. Plug in my a, b, and c. A is -1. -1 goes here, -1 goes there. B value is 4. 4 goes there, 4 goes there. C value is -13. -13 goes here, -13 goes there. Extend this out. All right, now it's just arithmetic. X equals -4 plus or minus 16, which is 4 squared, minus 4 times 1 times 13. Well, 4 times 1 is 4, times 13 is 52. I've got 3 negatives, so it's going to be negative, positive, and then back to negative, so minus 52. All over 2 times 1 times 13. 2 times 1 is 2, times 13 is 26. And I've got 2 negatives, so it's going to go negative and then back to positive. So this is my fraction. Let's see if I can clean it up some more. X equals -4 plus or minus 16 minus 52 is going to be -36 all over 26. Zoom in a little bit. So to finish this out, I've got -4 plus or minus the square root of -36. Well, we know the square root of 36 is just 6. It's -36. Remember, it's going to have that imaginary component. So I can rewrite this again as, zoom in some more. In fact, I'm going to fit it right here. It's going to be -4 plus or minus, square root of -36 is just going to be 6 times I all over 26. Well, 26 doesn't divide this evenly, but I can clean this up a little bit because 4, 6, and 26 are all even numbers. So I can divide all of it by 2. So this cleans up to -2 plus or minus 3i over 13. That's my x value. And if I wanted to write it out, I would write it out as -2 13ths plus or minus 3i over 13. And if I wanted to break it down into individual roots, I'd have x equals -2 13ths minus 3i over 13, and x equals -2 13ths plus 3i over 13. And that would be my answer. And it looks like I'm actually at the end of my quadratic derivation that I did. So going down from here, it'll be cleaner. So that was 2 complex solutions. Remember, just a quick review. When we have a quadratic, there's going to be 3 possible solution types: 2 reals, 1 real, or 2 complex. These are the only possibilities I can have. 2 real solutions means it has 2 x-intercepts. 1 means it has 1 x-intercept, which is also a vertex. And 2 complex solutions mean it has no x-intercepts. It's got complex roots or complex solutions. All right, so concept 2, the discriminant. So the discriminant, what this does, well, first off, in the quadratic formula, the expression b squared minus 4ac is called the discriminant of the associated equation ax squared plus bx plus c equals 0. So the discriminant is actually that part inside the square root. And what's nice about this is it can be used to tell us how many solutions a quadratic will have and whether they will be real or complex. So when you see the word discriminant, you probably think of the word discriminate, which unfortunately in our society has a very negative connotation because of all the horrible stuff that people do to people. But in the world of mathematics, all it's doing is basically making a determination between one thing or another, or it is differentiating between one thing or another, or clarifying one thing or another, deciding if it's one thing or another. So in the world of math, it's got a less negative connotation. Excuse me. So the discriminant, we can use this to tell how many solutions we have and whether they're going to be real or complex. So how this works is we can basically plug our A value, B value, and C value into that little part of the equation, b squared minus 4ac. And there's going to be 3 different possibilities. If b squared minus 4ac is larger than 0, well, that means I'm going to take a square root and I'm going to get a positive or negative value, right? If I take the square root of 4, I'm going to have positive 2 and negative 2. I'm going to have 2 real solutions. And that translates directly to a graph that has 2 x-intercepts. If I take b squared minus 4ac and get 0, then the square root of 0 is just going to be 0, so that plus or minus portion in the quadratic formula won't do anything. I'm only going to have that singular real solution. And then finally, if I take b squared minus 4ac is less than 0, then I'm going to have the square root of a negative number, which is going to result in some kind of imaginary situation. I'm going to have no x-intercepts, no solutions. And you can see that, excuse me, you can see that above. If you go to the 3 examples that we did, in the first example, we had square root of 29, 9 plus 20. That was a positive number, so it gave us 2 real roots, 2 real solutions, which we had over here. Excuse me. On the second equation, we had 400 minus 400, which gave me the square root of 0, which we threw out, which resulted in us getting only 1 real solution. And then finally, on the third one, we had 16 minus 52, which gave me negative 36, which gave me 6i when we took the square root, which is an imaginary value, which gave us 2 complex solutions over here on the right. So one easy thing to remember is if you got positive discriminant, you know you're going to have 2 real solutions. A 0 discriminant, 1 real solution, and a negative discriminant is 2 imaginary solutions. I want to take a second. Actually, I have room over here. Let's keep it all to the right. to talk about the big takeaway in the quadratic formula. So remember, the quadratic formula is made from the standard form. We did a bunch of work and we found that x is equal to the following. Oops. X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. Well, what I'm going to do is I'm going to divide this up into two pieces. Because remember, we're in standard form. If I break this up into two pieces, I'd like you to look at the left side piece first. Negative b over 2a. That is something familiar to us. This right here is our axis of symmetry from chapter 2. If I want to find the axis of symmetry on any quadratic in standard form, I can plug in negative b over 2a and I can find that. This other part of the quadratic formula, if you think about the graph, remember there are three different situations. One solution, or I'm sorry, two solutions, one solution, and no solutions, maybe something like this. Well, if negative b over 2a is the axis of symmetry on all of these, that's the axis of symmetry. This second portion with the discriminant, what this is telling us, this plus or minus and this weird number over 2a, this is actually the distance from the axis of symmetry to the intercept. So if I've got a positive value in this, I'm going to have two different values, one plus and one minus, that are going to give me two separate intercepts. And this is the distance from the AOS to the intercepts. So if I've got a positive value, I'm going to get a real value here that's not 0. And that's going to be the distance I have to go in each direction from the axis of symmetry to the intercept. If I've got a 0 value, well, that means I'm going 0 distance from the axis of symmetry to the intercepts, which means my vertex is the intercept. And then on the last one, if I've got a negative value inside the square root, then I'm going an imaginary distance from the axis of symmetry to the intercepts, because there are no real intercepts. This is like some kind of weird, crazy, magical world of complex numbers where distance doesn't really make sense. That's why we have 0 real intercepts. So you don't have to memorize this, but this is what this structure is telling us. This equation is giving us the axis of symmetry and the distance from the axis to the intercepts all in one place. All right, so let's do some stuff with the discriminant. So goal 2A, analyzing the discriminant. Find the discriminant of the quadratic equation and describe the number and type of solutions of the equation. Remember, all we're looking at is b squared minus 4ac. And we just need to know if it's greater than 0, less than 0, or equal to 0. So I'm going to do this very quickly. B on the first one is -6, so I'm going to have -6 squared minus 4 times a times c. Ooh, that's a bad color to use. Minus 4 times a, which is 1, and times c, which is 10. Well, -6 squared is going to give me 36. 4 times 1 times 10 gives me 40. 36 minus 40 is -4. -4 is less than 0. So this is going to have two complex solutions. The next two are just as fast. -6 is my b value, so I'm going to have -6 squared minus 4 times a, which is 1, times c, which is 9. That's going to give me 36 minus 36, which is going to give me 0, which is equal to 0, which means I've got one real solution. Ooh, going too fast. Last one, b is -6 again, -6 squared minus 4 times 1 times 8. I'm sure you can guess what this is going to work out to. I have 36 minus 32, which is equal to 4. 4 is greater than 0. That's going to be two real solutions. Oh, geez. It's just as fast as that. So we can now look at an equation and very quickly determine whether we have complex solutions, real solutions, and then how many of them we have if we're looking at real solutions. All right. I think this is the last example. Yes, it is. So writing an equation for a discriminant. So find a possible pair of integer values for a and c so that the equation ax squared minus 4x plus c equals 0 has one real solution. Then write the equation. So I'm looking at ax squared minus 4x plus c equals 0. And I know I want it to have one real solution. Well, we know from above that with one real solution that I know that the discriminant has to equal 0. So that means that my b squared minus 4 times a times c has to equal 0. Well, let's just substitute in what we know. The only value I know for sure is -4, my b value. So I'm going to have -4 squared minus 4 times, oops, I didn't change my color. Minus 4 times a times c equals 0. Well, that means that I've got 16 minus 4 times a times c equals 0. Now I just got to do some algebra. I'll rewrite it down here. 16 minus 4 times ac equals 0. I'm going to subtract 16 from both sides. So I'm going to have -4 times a times c equals -16. I'm going to divide by -4 on both sides. Cancel, cancel. I get AC equals 16 divided by 4 is 4. Negative divided by negative is positive. So I basically need to find an A and C that equal to 4. Does it want whole numbers? It wants integer values. So if it wants integer values, I need two integers that multiply to 4. I can do 1 times 4. I can do 2 times 2. I can do -1 times -4. And I can do -2 times -2. These are my 4 possibilities for A and C. I could also swap the positions. So I'm just going to pick one of them. Let's pick the first one, 1 times 4. I'm going to swap them though. I'm going to say A equals 4 and C equals 1. So if I plug those in, my equation will look like this. 4x squared minus 4x plus 1 equals 0. And now I've got an equation that has one real solution. And I can test that really quickly by just going into Desmos and graphing. Set it up as a function. 4x squared minus 4x plus 1. Sure enough, I've got one solution. And there we go. So this section, this whole chapter, the big picture idea is the quadratic equation. And then we get this nice little bonus of what we call the discriminant that's built into the quadratic equation. But with this, you basically have the way to solve any quadratic that you come across. So now we can solve things in multiple ways. For easy equations, it might just be straightforward enough to do taking the square root of both sides and solving, or factoring the entire equation to solve it, if it's an easy one. If it's a little bit harder, we could try completing the square, but that can be kind of messy, especially if our a value is not equal to 1. But what it boils down to is no matter what our a, b, and c values are, I could have, 32x squared minus 13x plus 61. And I can plug the a value, the b value, and the c value all into the quadratic equation. I'm not going to do that here, but I can plug all these in. It would be a horrendous mess because 13 is a prime number and so is 61. But you could do this, and you could find a solution or two solutions, and that would be your x values. And it'll work every single time, as long as you follow that equation. X equals negative b plus or minus the square root of b squared minus 4ac divided by 2a. All right, so that's it, guys. Please, starting on the homework, if you've got questions, shoot me a message. You know the usual drill. I hope that you guys are having a good day, and I'll see you soon. Thanks.